Hi, my name is Ben. Today, I will show how Singapore's rain reshapes taxi availability and why timing, place, and planning matter. The deck you see here is my video storyboard. Every slide is designed for clear perception, large type, direct labels, and colorblind safe palettes. Now, I want you to keep one question in mind. When the rain starts, how quickly do taxis vanish, and where does that storage shortage bite first? In this 5-minute video presentation, we will use the lead lag ribbon plot to investigate this. Now, I want you to imagine an evening downpour. Request spike, the map grays out, and the riders ask, where are the taxis? This presentation quantifies the experience. We study the short lead lag between rainfall and supply, then show how it varies by the Central Business District or CBD, residential areas, and industrial zones. The goal is practical, understanding the lag, anticipating the trial, and testing a simple what if to shrink it. Now, here are our objectives and two mini research questions. Firstly, we want to quantify the timing and magnitude. When does availability begin to fall relative to the rain onset, and how deep is this dip? Secondly, we want to locate where the impact is most significant. And for the rest of this presentation, we will progress from an exploratory overview to explanatory results. Okay, in this slide, we'll be talking about data and wrangling. We pair LTA taxi availability at 10-minute intervals with Meteorological Services Singapore rainfall from station gauges. To align grains, rainfall is forward-filled within the hour. Sources are spatially aggregated to 5 by 5 kilometer tiles and grouped by CBD, residential, and industrial classes. So this yields consistent, comparable slices for time relative analysis. And here, at a glance, we will shift from exploring patterns to explain mechanisms, beginning with our lead lag ribbon plot. So here's our lead lag ribbon plot. We center time on the rain onset and plot the percentage change in taxi availability on the y-axis against the percentage change against the minutes before / after the rain starts from -50 to +50 minutes. So here we use positioning and length, the most accurate channels in this chart. In the CBD, the sharpest dip or the anticipatory dip appears about 20 minutes before the onset of rain, and we have a trial near 20 minutes after the rain starts. In residential areas, this dip occurs later and is shallower as compared to that of the CBD. So here are our critical findings and implications. Firstly, the availability of taxis typically falls or dips within 30 to 40 minutes before the onset of rain, with the sharpest decline occurring at approximately 20 minutes before the rain starts. Secondly, the CBD experiences the deepest dip and has the slowest recovery among all the other zones. So now we have the conclusions and our next steps. So first of all, timing matters. Shorter leads and longer recoveries, especially that in the CBD, can be predicted. Second of all, the place matters. The towns warrant a different operational response as compared to that of the CBD, for example, and industrial areas. So in other words, place matters. CBD versus heartlands situation is different. Finally, planning matters. You need to set expectations during rain. For example, inform riders about expected recovery windows during storms, and we could even expand this analysis by widening the window to multiple seasons, rain season in Singapore, dry season. Can also incorporate wind direction and test what is with demand proxies. Thank you.